Next topic in Unit 3 is System Control Hierarchy. System Control Hierarchy. The control function required for the HVDC link is performed using hierarchical control structure. This is a system control. So reference power, master control, reference current, pole 1 control, pole 2 control, every pole having VGC. VGC is a valve group control. So this is a communication to remote terminal. So the protection of firing angle controls are very important. The overall system control is very important. For to maintain that one, we have taken as the reference power and reference currents. Every every group valve group can be protected by VGC valve group control. Every pole on particular part controlled by pole 1 control. We can control the number of parts by using pole 1, pole 2 and so on. So this in every pole control having valve group control. So every system having the system control and master control with reference values. The reference values are very important. The reference values always compare with actual values that will generate error signal. So why we generate error signal means how much deviation in a system is a very important for controlling the system. So we taken one reference values. For that reference we can compare with actual values. There is a deviation between reference and actual values that generate error signal. Based on error signal we can control the system. The master controller for bipole is located at one of the terminals and is provided with the power order from the system controller from energy control center. The power order is a P reference power. It is also has other information such as AC voltage at the converter bus, DC voltage, etc. The master controller transmits the current order I reference to the pole control units, which in turn provide a firing angle order to the individual valve groups, converters, individual valve groups. The valve group or converter control also oversees valve monitoring and firing logic through the optical interface. Normally, based on the reference power and the reference current, how much firing angle will be generate is a important. Based on the error signal, we can control the valves. The valve group or converter control also oversees valve monitoring and firing logic through the optical interface. It is also includes bypass pair selection logic, commutation failure, protection, tab changer control, converter start and stop sequences. How when the converter will be start, when the converter will be stop, that sequence will be includes in paired selection logic, commutation failure protection, tab changing control, margin switching and valve protection circuits. So the master control for bipole is located at one of the terminals and is provided with the power order P reference from the system controller. The master controller transmits the current order I reference to the pole control units, which in turn provides a firing angle order to the individual valve groups, that is a converters. So the master control the all pole controllers. The master controller, which oversees the complete bipole, includes the function of frequency control, power modulation, AC voltage, and reactive power control and frequency damping control. The valve group or converter control is a very important. The valve group or converter control also oversees valve monitoring and firing logic through the optical interface. It is also includes bypass pair selection logic, commutation failure protection, tab changer control, converter start and stop sequences, margin switching, and valve protection circuits. The pole control incorporated pole protection, DC line protection, and optional converter paralleling and deparalleling sequences. The master controller, which oversees the complete bipolar, includes the functions of frequency control, power modulation, AC voltage, and reactive power control and frequency damping control. So this is a block diagram of pole converter controls. This is a gamma measurement circuit. This is a gamma measurement circuit. So here the gamma is compared with actual value. So we generate one error signal, that is a gamma conjugate. So this is a gamma reference. The gamma conjugate always difference. Gamma reference is a positive, gamma conjugate is a minus. So that will generate an error signal. So disturbing magnitude also include this one in summing this summing point. So this summing point generate an error signal. So that error signal, the by using that error signal, the gamma controller take the selectors. Selector is nothing but which valve is conducts and which valve is stops, which valve is conducts, which valve is blocks, decided by the selector. So here also the current reference is there, so actual current is there. So this is a switch, so both are compared, generate the error signal. This is id controller. Based on this current controller, the selector decided which valve will be conducts. Normally in any converter or inverter station there are the number of valves. Based on selection, which valves are conducting, which valves are blocking will be selected by the selector. So based on that one, we can select vc is a control voltage. So based on that one, there is a decided the firing angle alpha. This is a block diagram of pole and converter controllers. The current or extinction angle controller generates a control signal Vc, which is related to the firing angle required. The firing angle controller generates gate pulses in response to the control signal Vc. The selector picks the smaller of the alpha determined by the current and CEA controllers. So this is a very important point. The selector picks the smaller of the alpha determined by the current and CEA controllers. Firing angle control. The operation of CC and CEA controllers is closely linked with the method of generation of gate pulses for the valves in a converter. The requirement for the firing pulses generation of HVDC valves are the firing instant for all the valves are determined at ground potential and the firing signals sent to individual thyristors by light signals through fiber optic cables. The required gate power is made available at the potential of individual thyristor. While a single pulse is adequate to turn on a thyristor, the gate pulse generated must send a pulse whenever required. If the particular valve is to be kept in a conducting state, the two basic firing schemes are individual pace control. Second one, equidistance pulse control. These are both are very important control systems. First one is IPC. Second one is EPC. IPC is a individual pace control. Second one is a equidistant pulse control.